Hi everyone, this is Sam from Developing Mathematical Thinking. In this video, we're going to talk about later elementary middle school idea, which is the quadrilateral hierarchy. That's essentially the organization of different quadrilaterals in a system that allows multiple names to be given to certain shapes based on their defining features. So we're going to take a look at this hierarchy in a direction that I think is really kind of helpful, and that's actually to start at the most specific quadrilateral, which is a square. A lot of times we'll start here at the top with a more just generic four-sided polygon, which is a quadrilateral, but sometimes it's actually nice to build from the sort of end of the hierarchy. Let's talk through how this hierarchy works. So with the square, we have a quadrilateral with all congruent sides and 4 right angles. If we decide that we're not going to require this quadrilateral to have all right angles, but we're going to force it to still have all congruent sides, we move up to the rhombus, which has 4 congruent sides, but isn't required to have the right angles. Kind of an interesting way to think about this, though, is that a rhombus having 4 congruent sides, a square also has 4 congruent sides and is simply a more special case of a rhombus. It's basically a rhombus with right angles. If we're not so worried about the side congruency, but we do want to stick with that requirement that the quadrilateral has to have 4 right angles, we move to the rectangle. Now, you probably focus on the idea with rectangles of these opposite sides being congruent. That's actually a byproduct of forcing the quadrilateral to still have 4 right angles, is these 2 opposite sides and these 2 opposite sides will always end up being congruent. So that's the distinction from a square moving out to becoming either a rhombus or a rectangle. So another way to think about the rectangle is that a square is a special rectangle where all sides become congruent. Not all rectangles will be squares, but all squares are special rectangles. The analogy I like to use with students is to think about a student's first and last name as being the most specific name for that student, but that student is also a student in a particular class, in a school, in a specific location, so they can belong to multiple groups. And that's kind of how this hierarchy works. So let's move to the next layer of the hierarchy. One of the features that rhombuses and rectangles have in common is parallelism. So they have these 2 pairs of parallel sides. So here you've got the 2 pairs, and then on the other sides, those are parallel. They'll never touch no matter how far they extend. So if we make that a defining attribute, we say, okay, this quadrilateral must have 2 pairs of parallel sides. That creates the parallelogram. Moving backwards from that, moving up the hierarchy to the least restrictive definitions, we can move to the trapezoid by focusing on at least 1 pair of parallel sides. That's actually been a source of controversy, and that definition has changed over the years. Most modern standards documents say that it's more helpful to have a trapezoid defined as having at least 1 pair as opposed to only 1 pair. That's a very exclusive definition. The reason why it's a little more helpful to have a broader definition of trapezoid is if you say that trapezoids have to have only 1 pair, then the parallelogram, this line would go away, and the parallelogram moves up here to this level of the hierarchy, and they become 2 different figures. In this case, the parallelogram is simply a more specific trapezoid, and it makes the connection from trapezoid all the way through the rest of the hierarchy much cleaner and more coherent. Moving back to this level now, thinking about removing the idea about parallelism, but going back to what we talked about with this layer here, the congruency of sides gives us a new quadrilateral, and that's the kite. And a kite simply is a quadrilateral where 2 pairs of adjacent sides are congruent. So for example, these 2 sides here are congruent, and these 2 sides here are congruent. But you'll notice we have a line connecting the kite back down to the rhombus. And that's because in a rhombus, you have 2 pairs of adjacent congruent sides. But unlike the broader version of a kite, in a rhombus, it could be any 2 pairs. In more general kites, or this particular version that you see pretty commonly, the 2 adjacent sides are always just these 2 and these 2. In a rhombus, it could be any of those pairs. And then moving back to where we have the fewest restrictions, all we're going to define the shape as a 4-sided polygon. So that's a closed figure composed of line segments. Then we end up with the generic quadrilateral that doesn't have any restrictions. So I hope that was helpful on what the quadrilateral hierarchy is. And please remember, when you're working with students, try to use that analogy of their name, their specific first and last name, to help explain things like how a square is a special rhombus, but not all rhombuses are squares. Okay, thank you very much.